I'm going to tell you a story about two extremes and the work that I'm doing in order to find a balance between them. But first, let's all just take a deep breath. So that felt good, right? This is because at the microscopic level, your lungs look like this image in the center here. They're full of air, which means your body can get the oxygen that it needs. So if this is what normal looks like, imagine how hard it would be to breathe if your lungs looked like either of the other two pictures. If you've ever known someone who's been diagnosed with severe pneumonia, their lungs may have looked like those. So what are these two extremes that I'm talking about? When you get a virus infection, there's a certain type of immune cell called the T cell that comes charging in to fight that infection for you. However, it turns out that in some cases, especially in respiratory virus infections, these T cells aren't very good at doing their job. They come in and they can recognize that there's an intruder, but they don't actually function properly. When this happens, this T cell is impaired, or what we call exhausted. When a T cell is exhausted, it can no longer fight the virus, and this virus wreaks havoc in your lungs. It gets hard to breathe. So essentially, we're trying to wage a war while our immune system has no interest in fighting that battle. Wouldn't it be better if we could tell our immune system, hey, wake up, we need you? But it turns out that if we flip the switch too far in the other direction, we run the risk of these T cells becoming overactive and attacking everything in sight, whether it's the virus or you and me. Our lungs become inflamed, and as it turns out, it's also hard to breathe. So understanding the balance between these two issues is the subject of my research. I'm interested in understanding the cells and molecules that regulate the process by which a T cell goes from functional to exhausted and back again. For example, we found that certain cell receptors, called inhibitory receptors, can mediate the switch from a functional T cell to an exhausted one. I've also found that when I disable certain regulatory cells, I can restore function to an exhausted T cell. Now, it's my hope that by better understanding these processes, we can find ways to fight infections by boosting our immune system's function. So somewhere between too much inflammation and too much virus is just right. And that's a breath of fresh air. Thank you.